Next, immutability. This we have already talked about. Anything that you declare as val, that is immutable, and anything that you declared as var, that can be changed, and that gets applied for not just the variables. Not just a plain data types, val type data types, also for your collections, and by default your collections are immutable. Okay, so any list is define a list as a immutable. Okay, anyway, we'll talk about collections in a separate slide more in detail. Okay, again, what are the collections that we talk in the functional programming concepts? This is just for your basic idea, and a complete list of all different types of collections list will cover after the OOPS concepts. Okay, so next concept is lazy vals. Lazy vals, if you for example, just understand this example, you will understand the concept also. So I have a function def hello, and inside this function definition I'm printing hello and returning 10. Okay, if I assign this function to a val a equal to hello, so what it does is, so whether I'm using this, okay, just simply, so what it does, if I do val a equal to hello, immediately after this line it prints hello and assigns that 10 to this. Okay, I just assigned val a equal to hello, so it printed hello, and it got 10 value, but it doesn't care about whether I'm using this a or not anywhere. Okay, so without caring whether I'm using this a or not, simply it executes this function, executes the function or expression, whatever you call, and gets the result of it and assigns to it. In case if I am not using this a anywhere in the sense, maybe if I'm using this inside my if else conditions and that else condition has never met, then unnecessarily I executed 2-3 lines of code, right? If that's the case, you have like a lazy vals declared, means at least if you are using once, and when you are using for the first time, then only this expression, this function will get called and value gets assigned. If I declare a lazy val b equal to or a equal to also, okay, hello, so now it didn't print hello or it didn't use this. If I use that a anywhere, then only it prints. See, if I'm using a in my println statement, so now I need to get the value of a to print that. So that time it executed the hello function and it got that value as 10. Just by assigning, it didn't execute that function. This is called lazy values, using that lazy keyword. So you can your execution will happen only at its first usage.
So what, like this LAZY, lazy, like is there any correlation to the way it's executed this function? Or is just a terminology given?
It's a terminology given, that's it. There is nothing correlated to hello function. Hello function is in both the cases, it's the same hello function only. It's lazy is assigned only or correlated to your variable value a, that's it. So if you declare a regular vals, if you are assigning a function, the function will get executed and the value will get assigned to it as soon as you write that assignment operation. And in case of lazy vals, only if you are using this a anywhere statements, in that case, while using that and only for the first time, this hello will get executed and value gets assigned. Any confusion? Same like, I mean, if you guys are, yes, like dump in pig, that's what I'm going to tell. Same like your dump or store command in pig, if you have a pig knowledge or if you have a MapReduce knowledge, lazy output format. There is an output format type called lazy output format. That lazy output format will create a output files only if it has at least one record to write in it. If you don't use lazy output format, if there is nothing to write, even then it will create an empty part-r files. You might have seen some MapReduce jobs producing if it is running a reducer, but the reducer file might be empty. Yep. So I'm assuming you guys got it. Let me know if that's not the case.
Good assumption, Shiva.
What should I do then? If you guys are not saying yes.
So, I mean, well, I don't know if it's just my problem or if it's everyone agrees with me on this. But if a real-time scenario would be, when and where to use this, like a scenario, like for example, I faced this issue and so I had to use this or this, like a case, if you could tell us a use case kind of a thing, it would be much more clear as to when and what type. Because right now we are just getting bombarded with so many functions.
I mean, these are these are very, very simple things. Okay. All other programming concepts are common in Scala as well, but these are simple things which I don't want you guys to miss that the Scala is providing. That's why I'm telling this. Just for
he may not be used all these.
You will not see you'll not find any significant real-time use case for usage of lazy vals. Obviously, see.
Why is it not good or is it bad?
No, it's not good. See, it's not a considerable example to tell. There won't be any considerable example. But for you to understand, let's say if I have declared a val, okay, and I am assigning some function, some expression is there. Okay, so that is a very big expression, like 10 to 20 lines of code. Okay. And the other way you are using in if-else conditions, like n greater than 0, do this, else, so else some a equal to a plus something or some any operation that involving a you are doing. If n greater than 0, you're not using a. Okay. So even in that case, if most 90% of the scenarios assume that your data will satisfy this n greater than 0 scenario. Okay. And you have assigned a function or some other expression to val a, or any function or expression, anything. Okay. So even though 90% of the scenarios will not fall into the else scenario, you're still executing this 20 lines of code all the time.
Okay.
Okay. But if you know where only 10% of the scenarios only will fall into the else condition, you can declare this as a lazy. Only For those 10% of the scenarios, this function 20 lines of code will get executed. Got it?
Okay.